Hi everyone, and welcome back to GISC 125, Mapping and Spatial Thinking. So today we're going to discuss a little bit about what social science is, what is included in that, and how spatial thinking is applied to social sciences. So social science tells us about the world beyond our immediate experiences and can help explain how our society works, from the causes of unemployment or what helps economies grow, to how and why people vote, or what makes us happy. So it provides vital information for governments and policymakers, local authorities, non-government organizations, and many others. So social science, kind of in its broadest sense, is the study of society and the manner in which people behave and influence the world around us. So spatial social science recognizes the key role that spatial concepts such as distance, location, proximity, neighborhood, and region play in human society. It promotes research that advances the understanding of spatial patterns and processes and invokes powerful principles of spatial thinking. So these are all things that we've talked about in this class up to this point. And there's been this huge explosion of interest in these applications of spatial concepts and techniques in the social sciences. And the development has been especially intense among those kind of researchers who are using it to work with data that are aggregated to different territorial units, such as counties, census tracts, states, neighborhoods, and so forth. So we will get more into that kind of in the coming lectures. So in the last slide, we kind of learned things about distance, location, proximity, and how they're important to the social sciences. So we're familiar with this map, and so we kind of locating an observation on a map is of use when it is evaluated in relationship to other observations, right? So this is what draws our attention when we look at a well-constructed map. The map maker has helped us perceive a spatial relationship, to notice where some kind of observations lie in relationship to others. So the map allows us to see these relative distances. So what do we do with these distances? What do they mean to us? Well, on this map, it means that the distance between the water pump and cholera deaths, right? We looked at the pump, the Broad Street pump, and what do we notice about that? Well, there's a lot of deaths very close proximity to that. So since these issues have a spatial component, GIS can play a large role in this. Therefore, in social sciences, if there's a geospatial component, GIS could be very powerful in helping analyze this. So the thing is that GIS and spatial thinking are not limited to just physical sciences, but also social sciences. So spatial-oriented social scientists often think in terms of neighborhoods or zones, and through these boundaries between them may not be explicit, such as some kind of political boundaries. They may be more very distinct. So especially when we ask, how about the consequences of living in this place versus a different one? We're implicitly defining places. There's also situations in the issue is not living a little nearer or a little further away, but in one place or in another. So looking at this county level poverty map, so do you think living in poverty in the South and the same health and life outcomes as those living in areas where the poverty level is significantly less? Probably not. Do you think those living in high poverty in the South had the same health and life outcomes as those living in poverty in Indian reservations, on Native American reservations? Maybe, maybe not. So let's look at a few other applications of spatial concepts in social science research. So research on population health often takes advantage of data at the incidence of the disease, kind of that point of where it happened. In this study of dengue infection in a city in central Brazil, collected survey data on over 1,000 individuals, and the survey included dengue infection status, medical condition history, and socioeconomic and demographic characteristics of those people infected with dengue. So this data was then aggregated to these larger areas. And so using this data, social sciences asked specifically whether there were zones of the city with significantly higher concentrations of infection, which could then be targeted for public health intervention, right? So understanding where dengue fever is high, you can focus your efforts on these certain areas and target that, as opposed to saying, okay, all of Brazil we need to, central Brazil we need to target. Well, apparently not, because you can see the prevalence rates in certain areas are significantly higher. In this map, researchers used student achievement and poverty data in Louisiana in 2009. And the distribution of schools in Louisiana by county, poverty level, and school performances, which are labeled A, B, C, D, and E, or F, As you can see, there's a great variation in the state with regard to the distribution of poverty, with the greatest occurring in the northeast corridor. So high-performing schools are spread across the state, but in many areas there are concentrations of poor-performing schools. So the map also shows that many schools are isolated and remotely located. So spatial techniques have the potential to explore these potential of these locations to impact school processes and outcomes. For example, do schools located in the middle of high poverty counties experience greater difficulties attracting qualified teachers than those located at the borders? So the results indicate that spatial correlation exists among schools in Louisiana with respect to math achievement, meaning that those close proximity to one another are more similar than would be expected by chance. So many serve students from the same families, neighborhoods, and may experience similar processes with respect to recruiting and retaining teachers and administrators. And here in this final example is what's the best way to measure human exposure to urban pollution? Typically, cities do this by studying air quality levels in fixed places. So New York City, for example, has an extensive monitoring network that measures air quality in 155 locations. But now a study led by MIT researchers focused on New York City, and it suggested that using mobile phone data to track people's movement provides an even deeper picture of the exposure of pollutants in urban settings. So to conduct this study, the researchers examined 121 days of data from April through July of 2013, using many types of wireless devices from a variety of providers, and blended the phone data with pollution information from this New York City's Community Air Survey. And so the result is effectively two different maps representing exposure to particle matter, one showing the exposure that is at a static or home-based pollution would have, and the other showing the actual exposure level given the dynamics of urban mobility. So by analyzing the issue in this form, the researchers believe they have demonstrated a new way of city leaders, health officials, and urban planners to obtain data on pollution levels and analyzing their policy options. So it becomes an interesting tool if you are a mayor and you want to take some kind of action. So your goal is to minimize exposure, and exposure is key determinant in human health. So these are just a few examples of how spatial thinking and geospatial tools are used to help social scientists look at and address questions